Hey, grade 11 physics. Last video for this week on dynamics. We got free body diagrams, kind of part 2. So we're going to talk about net force and what that means, as well as a little bit of friction and how gravity works its way into these questions as well. So let's get started with a simpler example when we're talking about net force. So let's first off understand what is net force. Net force basically just means that it's like the resulting sum of the forces in the actual diagram. So it's a lot easier for me to explain when I actually make an example than using the words. So let's just do that. So let's say that there is a box on the ground. All right, and it weighs, we'll put a mass over here of, I don't know, 10 kilograms. All right, there are 2 people pulling on it. Okay, one person over here, one person over here. Let's make their legs touch a little. All right. So there's a rope being attached to here. There's a rope being attached to here. Let's kind of make it actually. There we go. All right. So let's say that one person pulls with a force. It's a force applied of not force G, force applied. Force applied of, we'll say, 200 newtons. And this person has a force applied of about 300 newtons. So those are our 2 forces. Now technically there's still 2 more forces in this scenario that we have not put down. There's still a force of gravity. Take 10, multiply by 9.8, so you get 98 down. So force of gravity would still be 98. Thing is force normal. The actual ground holding up would still be 98 as well. The nice thing is they cancel out because they're in the opposite directions. Like the box isn't flowing through the ground. The box isn't somehow magically floating away. So those 2 always usually cancel out. Okay, so most of the time, force of gravity, force normal, for now, in the simple problems, will cancel out. All we have to do is figure out the actual net force of what's happening here. So let's just call this person Sam and Greg. So basically, net force is like, who's winning? The resulting thing. This person's pulling that way with 300. This person's pulling this way with 200. What's our net force? Well, our net force, you can kind of imagine, is, well, who's winning? Well, Sam's winning. So it is 100 newtons in that direction because this person's pulling with 300. Greg's pulling with 200, so 300 minus 200 gives you 100 newtons. So there's our net force. It is 100 newtons. Okay, so that's the overall resulting thing of net force. It's like, who's winning? Even if we added another person here, let's say we had another person here, and there's another string tied, and you added 50 newtons. These will both be going this way, this one will be going that way. Just find exactly which way direction it's going to go and by how much, okay? So that's how we find net force. So now we've got net force here. We have an F overall to find like our actual acceleration. F equals again mass times acceleration. Could I find how much this box is actually moving? Could I figure out how fast this box is moving? Well, we have a mass of 10 kilograms, and we have a net force, which is our F here, of 100. So yeah, we could go 100 here. Mass is 10, acceleration is a, so divide by 10. So acceleration is actually 10 as well. Acceleration in this scenario here would be 10 meters per second squared. And so that would be a question that's pretty common when we talk about simple free body diagrams. What are the resulting forces? What's the net force? And then what's the acceleration in this problem? So there's a really good example of, again, using net force to find an acceleration. Okay, so there's question 1. Let's do one with friction. So we're going to have one person here for now. Let's keep the mass the same, but instead of having Greg, let's just have Sam. Okay, so Sam, we still have a mass of 10 kilograms here, still mass. We'll even say that she's still pulling with 300 newtons, but we have, instead of another person, we're going to say there is a force of friction. So there's a force of friction, F-R-I. There's a force of friction that is going to be 120 newtons. Now, what does that mean? Where do I put this friction, like little arrow? Where does that go? We know that we have a force applied here. That's going in this direction. Thing with friction, friction is always working against the motion. So if I don't have anything here that works out. Yeah, let's turn this table just a little here. Let's say this marker here. If I'm pushing it this way, okay, That's not a good example. Let's say again, so if Sam's pulling the box this way, friction is going to be pulling against her. It's going to be slowing her down. If she starts to push the box and she wants to push it this way, friction is going to be going in the opposite direction. So friction always works to oppose the actual motion, wherever the motion is going. So I'm going to draw my friction the opposite direction. I'll draw with a different color marker just for fun. So because Sam's pushing that way, pulling that way, friction, force of friction, will be going in that direction with 120 newtons. All right, so we can ask the same question. How fast is this box actually moving now? Well, let's find our net force. So we can go to force and then net equals 180 newtons. 300 by Sam, 120 by friction in the other direction, so minus those. We have a net force of 180. And acceleration basically ends up being that force divided by mass. So 180 divided by 10. And this time we have an acceleration of 18 meters per second squared. So that's how we kind of work friction into these problems. Basically, it's always going to be going the opposite direction of whichever way the box or the object is going. So if car is going right, friction is going left. Kind of that way. Cool. All right, only one more example, and this is our gravity one. So we're going to do this. This one can kind of be confusing sometimes, but once you get the mental hang of it, hopefully it becomes a little more easier. Let's say there is Mr. Westwood here on the ground. I have a football in my hand. Okay, let's try and draw a football. It's not really that bad. All right, I have a football, and I want to try and throw it straight up. Okay. And I want to know when it releases my hand, what is the acceleration on the ball as soon as I release the ball, okay? So we're going to say that this ball, football, has a mass of, we're going to go with 0.5 kilograms. All right. Now we're also going to say that I apply an upward force applied in the upward direction. I apply a force of, we're going to say, I don't know, 60 newtons. 60 newtons. All right. Well, most people right away would say, well, you already have a mass, you already have a force applied. That's pretty simple. I can just go, acceleration equals 60 divided by 0.5. Like, I just move around my F equals m times a. Just take force divided by mass, and we're good. That's easy. The thing is, it's a little different here because I'm throwing the ball up against gravity. So gravity is going to have a force on this ball. Like always, anytime I throw this up, if there was no force of gravity, I could throw this up and it'd keep going forever and ever and ever. So gravity is going to have a force on this football as soon as I release it. So we kind of need to do a net force kind of idea here. So yes, this force applied is 60. That is for sure. But there is going to be a force of gravity pulling it down. So I'm going to kind of do this. This is the force of gravity on the football. Now, remember from a couple of the videos or the last one, to find force of gravity, all you got to do is mass times acceleration of gravity, the 9.8. So I have, to find this, I'm going to go the mass, 0.5, times 9.8, which is gravity. And that'll give me 4.9. Okay? So there is this force of gravity pulling down at 4.9. So now I can find a net force. If I'm still throwing up with 60, again, gravity is pulling down at 4.9, I can find that net force. And now I can actually figure out my problem. So my net force is going to be 55.1 in the upwards direction. That's newtons. And so now that I actually have that net force, I can figure out my actual acceleration. So now I can kind of go, well, 55.1 equals 0.5 times A. So I know that 55.1 divided by 0.5 equals acceleration. So my acceleration, if I do some quick calculator work here, is going to be 110.2. 110.2. That is really fast, meters per second squared. This football is flying. But that's okay. I don't think anyone could throw that fast, but we'll say Mr. Westwood can just for the fun of it. But that's how you would do this question here, okay? Anytime you're throwing something up, it's going to have there's going to be a force that is pushing down. Same thing technically if you actually throw it down, if you were on a tower and you throw it down, there's also an extra force helping you throw down. It's going to make it go faster. So just we have to make sure that if we have any kind of throwing up or down, we're not going to be throwing sideways yet. We'll do that soon. But if we're throwing up or down, we have that actual force of gravity in there as well. That's going to make us fly in that net force. So this is the most complicated kind of question I'm going to give you this week. There is one question on your assignment like this. So hopefully this video helps. Have a great week, physics. I'll be talking to you. I'll make sure I'm going to chat with each one of you sometime Thursday or Friday just to check in. And hope you guys have a great rest of the week. Thanks, guys.